Good day, everyone. Now, I am going to discuss about FRIEDMAN Fr test for randomized block. What is the FRIEDMAN Fr test? The FRIEDMAN Fr test is a non-parametric test used for finding differences in treatments across multiple attempts. It compares the distribution of measurements for K treatments laid out in B blocks using randomized block design. Basically, it's used in place of the ANOVA test when you don't know the distribution of your data. So for the formula, we have the FRIEDMAN test is equal to 12 divided by the number of blocks times the number of treatments times the quantity of the number of treatments plus 1 times the summation of the squares of the rank sum for all the treatments minus 3 times the number of blocks times the quantity of the number of treatments plus 1. In running the FRIEDMAN test, we need to take note of the following. First, data should be ordinal or continuous. Second, data comes from a single group measured on at least 3 different occasions. Third, the sample was created with a random sampling method. Fourth, blocks are mutually independent. And lastly, observations are ranked within blocks with no ties if possible. So let us now apply FRIEDMAN Fr test in this sample problem. In a study of the probability of reaction to antibiotics in children, 5 sample healthy children were used as subjects to assess their reaction to the taste of 4 antibiotics. The children's response was measured on a 10 cm visual analog scale, incorporating the use of phases from sad, which represents the low score, to happy, which represents the high score. The minimum score was 0 and the maximum was 10. The following data were recorded. So our first column, which is our 5 children, represents our blocks. Then our first row, which is our 4 antibiotics rather, represents our treatments. Applying now the steps in hypothesis testing, for our statement of the problem we have, is there a significant difference in the reaction of the 5 children to the 4 different antibiotics? With this problem, we have come up with 2 hypotheses. So our null hypothesis is there is no significant difference in the reaction of 5 children to the 4 different antibiotics. The second one, which is our alternative hypothesis, is there is a significant difference in the reaction of 5 children to the 4 different antibiotics. For the test statistics and level of significance, we are using the FRIEDMAN Fr test for randomized block for our statistical tool. Then we have 0.05 as our alpha, or the level of significance. We have 3 for our degree of freedom. And to determine our tabled value using the chi-square table, we get the intersection now of our alpha and our degree of freedom. So we have 7.815 as our tabled value. For the computation, we need to rank the 4 reactions of every child from the lowest value to the highest value. So for child 1, the lowest value is 2.5, so that will be our rank 1, followed by 5.8 as rank 2, then 6.2 as rank 3, then we have 6.7 as rank 4. For child 2, we have 6.6 as rank 1, followed by our 2 9.0, so that will be rank 2.5, and then we have 9.5 as rank 4. For child 3, we have the lowest value of 2.6, so that is rank 1, followed by 3.5 as rank 2, then 5.0 as rank 3, and then 6.6 as rank 4. For child 4, we have 5.3 as rank 1, followed by 7.9 as rank 2, then 8.4 as rank 3, and then we have 9.4 as rank 4. And lastly, for rank 5, for child 5 rather, the lowest values are 2.5, so that will be our rank 1.5, followed by 3.9 as rank 3, and then we have 7.5 as rank 4. Then we need to get the sum of ranks of all the ranks for the 4 treatments before applying the formula for the FRIEDMAN test. So we have the rank sum for treatment 1 of 12.5, then the rank sum for treatment 2 is 12.5 also. For treatment 3 we have 9.5, and lastly for treatment 4 we have 15.5. Applying the formula of the FRIEDMAN test, we need to substitute now the values for every variables we have. Since we have 5 children, so we substitute 5 for B. Since there are 4 antibiotics, we need to substitute 4 to our K. And then substituting now all our rank sums for every treatment and applying our knowledge in algebra, computing all of these, we have come up with 2.16 as our computed value. For our findings and decision, since our computed value earlier, which is 2.16, is lesser than our tabled value, which is 7.815, then our decision will be to accept the null hypothesis and not to accept the alternative hypothesis. For our analysis and conclusion, based on the data above, at 0.05 level of significance with degree of freedom 3, there is no significant difference in the reaction of 5 children to the 4 different antibiotics. The 5 children do not differ in their reaction to the taste of the antibiotics. They have comparable results. Thus, there is no enough evidence that the children's facial reactions have something to do with the antibiotics. So this ends my presentation. Thank you for listening, and God bless everyone.